Hello, my name is Chad Waters and I'm a registered environmental health specialist with Central District Health. This video is intended to cover the basics in food safety. Through examples shown here, you should learn enough to be fairly knowledgeable in how to prepare food safely in your establishment. There are many reasons to learn about food safety. First, foodborne illnesses are responsible for approximately 76 million illnesses, 235,000 hospitalizations, and 5,000 deaths in the United States each year. The cost of these illnesses is anywhere from $10 to $83 billion, and these are just reported illnesses. Actual costs could be much, much higher. Second, the cost to a food operation of having to deal with a foodborne illness is far greater than the cost of properly training employees. It only takes one mistake for an outbreak to occur, and it can severely hurt a business. Some of the costs might include lawsuits, increased insurance premiums, low employee morale, high turnover, which means training new employees, and negative media attention. Combined, these additional costs could result in closure of a food establishment. So as you can see, it is vital to practice food safety at all times. When we talk about what causes people to become sick from eating contaminated food, we group it into three categories or types: chemical, physical, and biological. Chemical contamination is easily described as some sort of harmful chemical getting into food, usually through improper storage or excess concentration. Physical contamination applies to objects that make their way into food, usually during preparation. Examples would be hair, bandages, fingernails, metal shavings, or parts of equipment. The third type of contamination is biological. This is what we'll focus on more than anything else. Biological contaminants are those small and most often microscopic organisms that are either a natural part of the food or are introduced into the food by improper handling. What are some of these biological contaminants that can cause illness? They're usually grouped into 5 categories: bacteria, viruses, parasites, protozoan, and fungus and yeast. Bacteria are single-celled and can grow anywhere. That means that bacteria do not need a living host, such as an animal or human, in order to reproduce. This is very important when we talk about food safety and the ability for bacteria to grow in certain types of food. Viruses are the second type of organism that can cause illness. Examples are hepatitis A and norovirus. Hepatitis B and C are not foodborne illnesses. Norovirus, sometimes known as the cruise ship virus, is very easily spread and can cause a lot of people to become sick at one time. The virus can also be spread for up to 2 weeks after symptoms are gone. That's why it's so important to practice good personal hygiene. It's also important to know that bacteria and viruses are not simply killed by freezing, cold holding, or hot holding. Throughout this video, we'll mostly be talking about bacteria and viruses. Parasites are typically common in fish, pork, and wild game. Cooking or freezing at specific temperatures, as well as purchasing food from approved sources, is important for parasite control. Protozoan, like viruses, must have a living host to reproduce. Examples are Giardia and Cryptosporidium. Fungus and yeast are the last group. Unlike bacteria, they require an acidic environment with low water activity. Fungus and yeast most typically cause food spoilage and are not usually a cause of foodborne illness. So what do bacteria need to reproduce? The best way to remember is by using the acronym FAT-TOM. The F in FAT-TOM stands for food. Bacteria need a high protein, high carbohydrate food source. Examples would be any meat, seafood, or poultry product, and any cooked plant food such as baked potatoes, pasta, and rice. The A in FAT-TOM stands for acidity. Bacteria cannot typically reproduce in a highly acidic food such as a lemon. The first T stands for temperature. Between 41 and 135 degrees, bacteria begin to rapidly reproduce. This is known as the danger zone. That's why it's so important to ensure that certain foods stay out of this temperature zone. The second T in FAT-TOM stands for time. If bacteria are given enough time in the temperature range between 41 and 135 degrees, then these organisms will start rapidly reproducing. The maximum amount of time that certain foods can spend in the danger zone is 4 hours. Time and temperature are very important in food safety to prevent rapid bacterial growth. The O in FAT-TOM stands for oxygen. Some bacteria require oxygen. These organisms are considered to be aerobic. Some do not require oxygen. These organisms are called anaerobic. The M in FAT-TOM stands for moisture. Bacteria need a moist food to grow in. Plain water has a water activity of 1.0. Bacteria require water activity of 0.85 or higher. When we talk about what bacteria needs to grow, we use the term potentially hazardous food. These are foods that have the potential to cause foodborne illness if not handled properly. They are typically high in protein or carbohydrates, moist, have a slightly acidic or slightly neutral pH, and have a history of causing foodborne illness outbreaks. As you can see, these foods meet most of the Fat Tom criteria.
After the first video, we have to come to a photograph from one of our actual operations. So I see something wrong with this picture, and I'm going to ask Amy to also state what's wrong with this picture. You're right. It's not being properly thawed because the food is not completely immersed in water. All surfaces are not covered, even though the water is running. But more importantly, let me explain the history of this photo. This is a pot sink. It happens to be the sanitation sink, and what I see is the possibility of physical contamination coming from the drain and from the backflow. We also have chemical sanitation in this particular area, and right next to it we have the garbage disposal. So the possibility of contamination here is a lot. An employee comes up and starts running the garbage disposal, you can see barely that the water has splashed up because there's no guard on that particular garbage disposal. Now when we take temperatures of this, what we're going to have is a surface temperature that may be appropriate and out of the danger zone. But the internal temperature at the thickest part is going to be inside that danger zone. Any questions about the first film strip? Anything that needs to be clarified? Remember, Fat Tom. Second video.